All right, now we're going to look at a case of calculating yield to maturities and future price. The question says a bond has $1,000 par value, 10 years to maturity, and a 7% annual coupon rate. And it sells for $985. Part A says, what is the yield to maturity? Now, we know from the formula, yield to maturity. To calculate the approximate yield to maturity, we'll need the coupon payment. And we take our par minus our price, all of that divided by the time to maturity. We add these two for our numerator in our formula. And for our denominator, we're going to take the average of the par and the price. So that's par plus flat price divided by 2. Now, in order to calculate the elements over here, we already know that the par is equal to $1,000. They've already given us this in the question. We have 10 years to maturity given right here in the question. And the price is $985. Now, with a coupon rate of 7%, we'll be able to calculate the coupon payment, which is always equal to coupon rate multiplied by the par value. And so the coupon rate of 0.07 multiplied by the par of $1,000 gives us a coupon payment of $70. And that's going to be the final input over here. Now we take all of the things that we know and plug them into our formula with a coupon payment of 70 plus a par of 1,000 minus a price of 985. All of that divided by 10 years to maturity. That's our numerator. And in our denominator, 1,000, that's par plus price 985 divided by 2. So one by one, we're just going to go ahead and plug that into our calculator. 1,000 minus 985 is 15. 15 divided by 10 is 1.5. So 70 plus 1.5 is 71.5 in our numerator. And then we've got 1,985 divided by 2. And that gives us 992.5. So 71.5 divided by 992.5 gives us 0.0720 or a 7.2% yield to maturity. Now in part B, it says, assume that the yield to maturity remains constant over the next 3 years. What will be the price 3 years from today? So to calculate the price 3 years from today, that means that our time to maturity is going to change. If today we've got a yield to maturity, a time to maturity of 10 years, then 3 years from today, our time to maturity is going to be 7 years. Our price will remain exactly the same as 985. Our par has not changed either. That's $1,000. And of course, our coupon payment has not changed either. That is 70. But what we're going to do now is we're going to plug that into the price formula. And to calculate the price, we need the coupon payment. And this can be the annuity portion of our formula. So 1 minus 1 plus I to the power of negative n divided by I. All of that, and we're going to add in the present value of our par. So par divided by 1 plus I to the power of n. Okay, so taking all of our known variables over here, our coupon payment is 70 times 1 minus 1 point, and our yield to maturity is what we've calculated over here. So that's going to be R. R equals to our yield to maturity, and that's 7.2%. So 1.072 to the power of negative 7, because remember our time to maturity is now 7 years, 3 years into the future, divided by 0.072. Plus our par value of $1,000 divided by 1.072 to the power of 7. All right, so plugging that into our calculator one by one. 1.072 to the power of negative 7. 1 minus our answer. $1.072 to the power of negative 7. And 1 minus our answer. All of that is to be divided by 0.072. And all of that is to be multiplied by 70. And so the first component that we get is 374.63. That is the contribution of the coupon payment into the price valuation. And then on the other hand, we want to see the contribution of the par value. So 1.072 to the power of 7. And we want to take 1,000 divided by that answer. And so we get 614.66. If we add these two numbers, 374.63 plus 614.66, we get 989.29. And so the price 3 years from now is going to be $989.29. That is the answer to part B. If you have any questions, don't forget to comment below. Don't forget to like and subscribe. Thank you.